Hey guys, welcome to video 5-1. We're going to be talking about exploring what makes triangles congruent. In this video, we're going to talk about how it is that we are able to show that two triangles are congruent. And so we're going to look at, first off, kind of a new statement that comes from our corresponding parts of congruent figures statement, which is CPCTC, remember? To change that to if two triangles are congruent, then instead of corresponding figures, the corresponding parts of the triangles are congruent. And this statement is sometimes, you guys, referred to as CPCTC, so highlight that right there. And then, of course, the converse is also true. Instead of knowing that the triangles are congruent, we can also go from knowing corresponding parts are congruent, therefore the triangles are congruent. So CPCTC is our new kind of statement. What you need to know, you guys, about CPCTC is that it means that embedded in the congruence is that 6 smaller congruent statements can be written, which means that there are actually 6 things or 6 congruences to look for and to check out in order to prove that any two triangles are congruent. 6 pairs of corresponding parts, meaning 3 corresponding angle pairs and 3 corresponding sides pairs, okay? So from here, actually, we're going to skip ahead a couple of pages. Go to page 221. And on page 221, we have with explain 1 here, deciding if triangles are congruent by comparing those corresponding parts. First, we're going to talk about the definition of a biconditional, as you see here. A biconditional is a statement that can be written in the form P if and only if Q. Basically, what that means is that both a statement and its converse are true. And so that's what you have here. Two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. So let's look at example 1 that they've given us here. In example 1, we're determining whether the given triangles are congruent. So we want to first off see, are there corresponding pairs of sides that are congruent? So what I would do, you guys, is I would look at triangles as having a small, medium, and large sides, okay, and seeing if those small, medium, and large pairings are congruent. So as we look through here, it says GH is congruent to KL, and so GH is here, KL is here, and they are both 1.7. HJ is congruent to LM, so if we're kind of following along, those are our small sides there, which are both equal to 1 meter. And then GJ and KM are both 2 meters. So my small, medium, and large pairings of angles are all congruent. Then, so that's out of right here, that's 3 of 6 is my sides, okay? And then I'm going to go now and talk about my angles. So what would G go with? Well, G would go with the small angle on the other triangle, which is K, and they're both 30. H would go with L, the biggest angle, which are both 90. And then the medium size angles J and M are congruent at 60 degrees each. So we've got 1, 2, 3 pairs of corresponding angles. So once we've got those 3, we've got our 3 and 3, which are going to equal, and that's all 6 pairings of your corresponding sides and angles. And again, You have to have all 6 in order to prove that they're the same. If there's a failure in that process in any way, then you cannot determine that the triangles are congruent, okay? But because I've got all 6 going on here, we can now go ahead and say that the 2 triangles are congruent. And notice that the order of those letters is in corresponding order, so that's important to keep in mind too. All right, let's go to the next part of example 1, and now we have 2 new triangles being given to us, and we're trying to determine, are they going to be congruent or not? So we're going to compare corresponding sides. They've taken AB first. As you can see, AB is the longest side, so let's compare that to the longest side of the next triangle. Those, you guys, are both 12.1 centimeters, and so that means that AB is congruent to DE. And again, please make sure you're making note of the difference between when those letters are given to you without this segment symbol over the top. That means it's looking for a length, and notice there's our units there, so that's also a giveaway. And then when the segment symbol is used, we're going to be looking for a name of a segment with a congruence symbol. All right, so that's our biggest pair of sides. Those are congruent. Let's look at the next pair. AC next is what they give us. AC, that's the shortest side. What's the shortest side over here? 7.9 and 7.9. Okay, so those seem to correspond. Let's go ahead and fill that in. AC is the same length as DF, which is also 7.9. So we've got a second pairing of congruent sides. That means segment AC is congruent to segment DF. However, it says as we look at the third pairing of sides, CB and EF, those are not the same value. The lengths of those sides are not the same value. 8.5 and 8.4 obviously are not the same length. So BC is not congruent to side EF. So the triangles are not congruent because not all pairs of corresponding parts are congruent. And notice that you don't even need to check out the angles on this one, because you've had a failure or a breakdown in the system here. Okay, you don't even have to check out the corresponding angle pairings, because the sides end up failing, that they are not congruent. Okay, so that's what we're working with in this section. Pretty straightforward. Go to the next page, please. And we're going to be working on doing your turns and I need you to do your turn 4 and your turn 5 here. Again, just giving you 2 triangles and going through to see whether they have corresponding sides that match up or not. So take a look at that your turn before we go on to explain 2. Okay, in explain 2, you guys, we're going down to talk about how we're going to apply the properties of congruent triangles. And we're going to ensure that the triangles are congruent by basically setting missing pieces congruent and corresponding pieces, of course. We may have to use the triangle sum theorem, which, remember, talks about how all the angles are going to add up to our magic number 180 degrees. We're going to explore that theorem a little later, but remember that's what it says. So if we have a missing angle, we want to do a subtraction from 180. Let's take a look at example 2 on page 223. In example 2, it says find the value of the variable that results in congruent triangles. So first off, what we need to do is identify what the corresponding angles are. So we can look through here and we can say angle M is our 55-degree angle. That goes with angle J. And then we also have angle N is congruent to angle K, so those are congruent. And then, of course, the only piece left is that angle P must correspond to L. So our task is to figure out what the measure of x is, or first off, figure out maybe what the measure of angle P is, and then see where we can go from there. So since we know that angle P corresponds to angle L, let's see if we can do some math to figure out angle L. So that's where we use the triangle sum theorem. If we know all three angles here add up to 180, then we can substitute what we know, which is 55 for J, 45 for K, and then the measure of angle L is our unknown. Doing some quick addition and then subtraction from 180, we know that our missing angle here is going to be 80 degrees. I'm going to put that on the diagram because sometimes it's easier to see the corresponding pairings in their locations. So now that we have the measure of the missing angle L and we know that L and P correspond, I'm going to set up a new equation to find the value of x. So what we have here in step 3 is that measure of P equals measure of L, so 5x plus 30, which is the algebraic expression for the measure of P, is equal to 80. Subtract your 30, do some algebra there, divide each side by 5. As you can see, we get an angle, a value for x of x equals 10. Now let's remind what we were doing here at the start of the example, because sometimes we get a variable, remember, and we have to do more with it. Let's see what the instructions were. At the top we see the instructions were simply find the value of the variable that gives us congruent triangles. Okay, so I think we're done with this one. Let's look at example B. Example B, same instructions, find the value of the variable that makes the triangles congruent. So we're going to identify corresponding sides this time because it looks like we've got corresponding angles all good to go. Angle A corresponds to angle what? Well, we're going to look at what marking that has. That has only one arc mark on the angle, and that must go with angle D then. And angle B has 3 arc marks. That goes with angle E, which also has the same markings. And C has 2, and so does F have 2. So if we're looking for side DE corresponds to side AB. So if we're going to write an equation, DE is our missing, has the variable in it. So if DE corresponds to 36, because those measures are the same, then 2y plus 20 equals 36. Then 2y equals 16, and y must equal 8. And we found the value of the variable. Go to the next page, you guys. We're going to be doing similar things here with your turn number 7 and 8. And again, you're just finding the value of the variable that makes those triangles congruent. All right, we'll see you guys next time.